Hello, Tableau Conference 2018. How's it going? How's everybody doing? Yeah. 17,000 data enthusiasts under one roof. What a phenomenal conference, right? Welcome, and hello to everyone who's tuned in live from across the globe. Welcome. Welcome to our session, Advanced Visual Analytics at Scale, Empowering Actionable Insights at Verizon. To introduce myself, I'm Siddharth Dayama, and I lead data visualization at the Contact Center Analytics team in Verizon's Analytics Center of Excellence, ACE, as we like to call it. Prior to Verizon, I worked at WTA Networks, led finance and analytics, and I got to work with some of the world's best tennis players at that time, including Maria Sharapova and Novak Djokovic. My academic background is primarily in finance, and during my master's at NYU, I got particularly interested in the Ethereum blockchain. So in a nutshell, you'll find me creating data visualizations during the day and trading cryptocurrencies at night. So if any blockchain enthusiasts out there, let's talk. I've used Tableau to explore the space, and we can have some good discussions. With me today, I have Greg McConney.
Thank you, Sid. So my name is Greg McConney. I lead the Contact Center Analytics team at Verizon, or in the Analytics Center of Excellence. A little bit about myself. I studied physics and math in college, which led me right into a business intelligence role in the insurance industry. In that role, I built lots of SQL queries, lots of predictive models, or as they like to call them today, machine learning and AI. After that, went into a little bit of analytics consulting, and about 2.5 years ago, joined Verizon, and I've been doing customer engagement analytics ever since.
So what are we going to talk about today? We have two main sections for today's presentation. In the first one, we'll talk about who we are and what we do, so the different businesses that fall under Verizon Consumer Markets. And then we'll look at how does that translate to big data at scale. We'll touch upon how does that data flow across the organization, so the different pieces of our data ingestion pipeline. And then we'll look at how we've organized certain resources and applied certain best practices in our data science teams. Before I get into the second section, a quick show of hands. How many of you actually develop Tableau dashboards at work and beyond, like you Tableau developers? Sweet. So this section of the session is dashboard heavy. And we'll get into the nuances that are involved in creating effective views and visualizations in Tableau. So in this section, we'll talk about how we use visual analytics at Verizon to solve complex business problems. And we have 4 area-specific case studies. We'll touch on how we use data to optimize call center operations so that we reduce the need for customers to call us multiple times. Customers hate calling us multiple times. How can we optimize field technician dispatch operations to reduce the need for dispatches being generated altogether? Customers do not want to stay at home and wait for a technician. Then we look at how can we use data to help launch new digital products, to enable customers to engage with the Verizon brand more and more in an intuitive and seamless fashion. So in this one, we'll cover a few chatbot use cases. And in the last one, we'll look at how can we use data to design experiences, digital experiences, so that we make it easy for customers to self-serve online. And in this case, we'll particularly talk about how can they renew their contracts online. So what is Verizon Consumer Markets and what is Fios? Verizon Consumer Markets provides residential connectivity solutions, including home internet, cable TV, landline phone connections. And all of these services are offered on top of our 100% fiber optic network under the brand Fios. Fios is the largest fiber optic network in the US. And we also offer the fastest home broadband speeds through a gigabit connection. So let's look at a few numbers. We've got 6.9 million broadband connections, 4.5 million TV subscribers, 12.2 million landline phone connections, covering 10 states, primarily on the East Coast. And all of this translates to big data at scale. To give you a sense, 200 plus server nodes at 15 petabytes of data warehouse capacity, we generate 4 plus TBs of data every single day through the activity that happens on our online digital properties and the call center operations and the dispatch operations. And in a minute, Greg will talk about from where does this data get generated. More than 2 petabytes of data is extracted from our warehouses every single day by different analysts and different data scientists in the organization for in-house analysis. And strictly from a Tableau perspective, we have a 2 TB on-premise Tableau server on which, at any given point of time, we have more than 55 GBs of data extracts published that power our dashboards throughout the organization. With that, let me turn it over to Greg to talk about how does this data flow across the organization.
Thank you, Sid. So we want to talk a little bit how our data moves from our source systems all the way to when you see visualizations. So on the very left, you see a lot of our systems. You have digital activity, customers engaging with our mobile apps or our website. You have customers engaging with our products. You have call centers. People want to call to sign up, inquire about pricing. You also have service questions, people looking to change things on their account. You also have tech support. Have you ever had a problem with any of your equipment? Well, you might need to call and get that fixed. We also have dispatch centers. We may need to send someone out to your house to do your installation or to repair if you're an existing customer. You need to take all that data and then move it into our data warehouse. So we have an ingestion layer. And when it gets into our warehouse, we use 2 different products primarily. So it's mostly Hadoop and Teradata. So Hadoop stores most of our large data, which is our online data, and Teradata stores most of our offline data or our smaller data. It's critical that we are always connecting those 2 things together. So when you get into the querying part and the analysis part, we use things like Hue and Squirrel and Teradata, SQL Server, whatever is really needed to pull the data. And once you've pulled the data, we need to analyze it. So we use a lot of different technology to analyze data. So a very common interview question that I might get from a candidate is, if I were hired as a data scientist, what technology could I use to generate my insights or build my algorithms? My answer is very simple. You can use whatever you want. We like to be open to letting data scientists use whatever technology they want to use to be most successful. But I will say, by far, we use R, SAS, and Python for most of our models. And I'll hand it over to Sid to touch upon the visualization software that we use.
Thank you. So once the analysis is arrived at by the different data scientists in the team, it is extremely crucial to, 1, distribute those insights to the decision makers in the organization in a consumable fashion, in the most intuitive way, in the most visual way. And 2, to automate those insights so that they can be monitored timely moving forward without having to go back to the drawing board, without having to redo the work and rewrite the queries. So Tableau Desktop and Tableau Server are our primary visualization and reporting tools at Verizon, through which we distribute insights to the decision makers in the organization. And I should say, in a manner which is more and more self-serving, thanks to the capabilities Tableau brings in. So Tableau dashboards are used across the organization by different operations managers, business transformation teams, product managers, marketing managers, even software engineers. So particularly in the chatbot use case, we'll talk about information from our dashboard, insights from our dashboards have been extracted by software engineers to enhance the capabilities of the chatbot, to train the intelligence on the bot. We'll take a look at that. And last but not the least, our executives and leadership who set the direction of the business. In the next slide, we'll talk about the different functions that fall under Analytics Center of Excellence.
Thanks, Sid. So we want to touch upon our organization because we think we do analytics very well. We kind of want to walk you through our different pillars. So we have 5 different pillars. And really, who are these people? These are the most amazing people, data scientists, visualization experts, who have one common goal. We all want to solve complex business problems with data, and we want to deliver an unbiased view of results to the business. We don't want to see gut feel decisions. We want to see informed decisions be made that move our business in the right direction. So the first pillar I want to talk about is data governance. Data governance, it's the least sexy of the analytical functions, but everything would fall apart without it. This is data management and governance. This is ensuring that clean and usable data is ingested into our data warehouse so that we can actually do reporting and analytics. The next layer is BI and reporting. So many of you are familiar with this. This is all about performance management. This team makes sure that every single team in the organization has what they need to understand performance in every capacity. What's actually most impressive about this team is, as many of you know, they need information in different ways. You have leaders who need emailed reports. You have leaders who want dashboards. You have leaders who want Excel reports. They have to make this happen, and they're able to fulfill all these requests successfully. The third pillar I want to touch upon is digital analytics. Digital analytics is all about site pathing analysis. And as more customers start to engage digitally, this is increasingly important. So to give you an example of what this team does, is you have 100 customers over here, but you need them to get here. They make sure that if a bunch of those customers are falling out in between, they need to find out why. We want customers to be able to self-serve seamlessly. The fourth pillar is voice of the customer. Voice of the customer is all about leveraging what our customers are telling us. So we have surveys, we have speech through our chats, and we also have, speech through our calls and text through our chats. They make sure that we're hearing our customers and making improvements to our business as needed. Now, the last pillar, and certainly not the least, is my team. It's contact center analytics. We are an end-to-end team who we pull queries, we generate insights, and we deliver those insights to the business. And we're comprised of 3 different layers. We have chats, call centers, and cross-channel. Cross-channel is super important because what it really tries to do is take customers who are digital, and a lot of them, for some reason, end up going to the call center. We consider this a failure. So we want to understand why exactly are those customers needing to go from digital to the call center instead of self-serving seamlessly. So the next topic we want to cover is all about our workflow. And the purpose of this slide is really to put emphasis on data scientists working together with data visualization experts. So the first stage of the analysis is all about the request comes in. It sounds like the most simple thing in the world. It's just the request comes in. It's actually one of the most complex. You need the data scientists meeting with the business and the stakeholders to make sure that they understand their requirements in full. Because what you don't want to happen is get all the way down the process, you're generating insights, and you miss the whole purpose of the problem. Because then you're going to have to go right back to the beginning. So super critical for us. The next stage is all about building query and generating insights. This is where we write our SQL queries, pull our data together, manipulate it and clean it, and generate insights, build predictive models, whatever is needed to solve the problem. Next stage is sharing with the stakeholders. This is where you finally solve the problem, you're ready to share with them, you sit down, you meet, and you make sure everything is good. Once that's done, number one, you want action to be taken. We're not here to generate insights to generate insights. We're here to generate insights so that the business can take action and improve. So the second thing that can happen at this step is automation. This is where the business needs to automate the results because they need to monitor these insights moving forward. So that's where the automation piece comes in. So at this point, we might have to go through another stage of optimizing our queries. It's not that we wrote a bad query the first time, it's that we take our queries very seriously when they feed dashboards, and we want to make sure that they're perfect. So at the next stage, we'll draw up the dashboard, put all our design hats on, the right chart for the right data. We'll create the tool. And one area we want to touch upon, which is super important, and I'm glad to see a lot of sessions were about this week, is the governance and security component. So you need to make sure that not everyone can see your dashboards. Dashboards are meant for certain teams, and you need security there to make sure that they're the only ones who have eyes on that. So to get to my next slide, this is all about avoiding bad queries. And the reason I wanted to have this slide is it's super important that your dashboards load quick. So true story, when Sid actually joined the team, I told him that no dashboard could take more than 5 seconds to load. This is because I had seen dashboards take so long to load, and I know what that does to the stakeholder. They don't want to wait for their data. So let's all give Sid a round of applause because he actually makes this happen, and all of his dashboards load in less than 5 seconds. So it's really awesome that we're able to deliver that. So the first piece I want to cover is avoid inefficient queries. If someone told you to write a query by select star from left join, left join, left join, left join, all the way down, avoid that. The reason is you're doing full table scans. You're pulling all this massive amounts of data into your dashboard, and it's going to take longer to load. So what we try and do is, step 2, write an efficient query. This is leveraging subqueries. So you want to reduce your data down first, join it together at the end, and then get your output. But it doesn't stop here. So what we try and do to make our dashboards load as quickly as possible is we try and aggregate our data when we can. So this is all about creating smaller tables. So we might take that efficient query, create a smaller table, and now we've taken all this massive amounts of data and reduce it down to a smaller table. But I will say it does not even stop there. To ensure that our dashboards load in just super fast, we aggregate the data one more time if we can. So if you're trying to show a chart that's one dimension by 3 metrics, why pull in all the data? Just aggregate the data one more time, group by the dimension you're trying to show, and there you go. You're going to have an extremely fast dashboard. So if you follow these steps, I guarantee you can meet the 5-second rule like Sid over here. So with that, I'll pass it over to Sid to get to the really awesome part of this demonstration, which is our amazing case studies.
So in the agenda, I talked about we'll be covering 4 area-specific case studies, and we'll look at how we optimize call center operations, how we optimize dispatch operations, how we use data to launch new digital products, and how we use data to improve the digital experiences. But before I get into the case studies, I want to touch upon the thought process that goes behind creating these dashboards at Analytics Center of Excellence. So rather than creating ad hoc reports or building ad hoc views for the micro asks that come in from different stakeholders, we try to build end-to-end business intelligence solutions through Tableau dashboards. And in the demos, you'll get a sense of what do we mean end-to-end BI solutions. And the objective here is to democratize and distribute data so that the business experts, the stakeholders who are on the front lines of the business, can slice and dice millions of rows of data themselves without having to write code and extract actionable and valuable insights whenever they need, at will on a near real-time basis. With that, let's get into our first case study. So as I mentioned before, in our call centers, we have a few customers. We have certain customers who call us multiple times, repeatedly, on a recurring basis. So the objective here was to improve customer experience by analyzing and monitoring calls from customers who are highly engaged with our call centers. And to do that, the first step is to identify who these customers are and why do they call us. So we start with customer segmentation, and we look at 17 different individual attributes for every single individual in our customer base. So this is at the customer level, customer segmentation at the actual customer level. Once we've identified these attributes, we monitor their calling behavior and categorize these customers into different cohorts to be treated. And the way these customers are treated is when they call us the next time, they are routed to special teams of reps, which include some of our best and the most skilled call center representatives. So once the routing takes place, it's time to measure the program benefit calculations. At this stage, basically what we're trying to answer is, how has the calling behavior for these identified customers changed after routing to the special call center representatives? And once we see promising results, the next question is, how do we scale this project to include more and more customers? But before that, a key question we need to answer is, do we have enough operational capacity to scale? And so for all of these steps in the process, for all of these different stages of the project, we've used Tableau dashboards, tools through Tableau dashboards to answer these key questions. So before I get into the dashboards, I want to say this. We've used actual dashboards, but the data points have been redacted by replacing them by pound signs. And you would see certain sensitive information being blurred. But these are actual dashboards that we use every day, like right from our analysts to our executives. And so what you will be seeing are screen captures of these actual dashboards. And the way we've redacted is, it's just changing the labels. So when I show you the slicing and dicing of data, there's actual 6 million rows or there's actual big data being treated under the hood of these dashboards. So let's look at these hashboards, if you would will. Once a cohort is selected at the top right, at the top left filter, excuse me, you can see certain customer segmentation, not only on an overall basis for the cohort selected, but the table at the bottom shows you each individual customers and 17 different attributes that we monitor for these customers. And to give you a sense of what we look at where the customer comes from, how long the customer's been with us, what products they use, what age group they fall in, how often do they call, on an average, how long are their calls, what is the average call sentiment, and other attributes. So once these cohorts are created and once these customers are routed, in the next few, we look at how the calling behavior for these customers have changed. And in the table at the top, what you see is we look at certain pre-routing weekly averages, and then look at post-routing weekly averages, and then compare the weekly average reduction percentages for key KPIs that answer questions such as, are we now resolving these customers' issues better post-routing? Are the customers more satisfied post-routing? And by how much has the call volume, dispatches, and billing adjustments gone down post-routing? And from the data, there's an interesting thing that we see, which is the fact that if you take care of the customer, as a byproduct, you start solving for reducing operational costs. So as we see the resolution rate go up, as we see the satisfaction index go up, the call volumes, dispatches, and billing adjustments go down proportionately. So that's a really interesting insight that we see. The time trend that you see in the line graph below shows you the decline in call volume post-routing, so decline in call volume after routing to the special teams of reps. And the reference lines that you're seeing show you when each cohort is routed. So in a sense, it's giving you a sense of the project life cycle. So one feedback that we got from our stakeholders was, OK, it's great to see the call volume going down post-routing, but we want to compare how these cohorts have performed against each other after routing. Now, each cohort is routed at a different date. So for that, we wrote certain date alignment logic, which is using date trunks to extract the week of the routing date, and then using date diffs to calculate the number of weeks it has passed since routing. And what you arrive at is the line graph, which you see at the right, where you see cohort 1, cohort 2, cohort 3, cohort 4 stacked up along each other to show you what was the result during week 0, which was the week of routing, during week 1, during week 2, and 3 weeks after routing, and so on and so forth. The bottom of the dashboard is the call volume calendar heat map, daily call volume calendar heat map for 9 months. So you can see Q1, Q2, Q3, showing you a daily call volume. And it is good to see that as the project progresses, we move on from a whole lot of yellow and red to into the green. So it's an intuitive way to see if a cohort is performing good or bad. And this type of a view is not a default chart in Tableau, but you can use row index functions and column index functions and build the view and overlay dates on top of that. Tableau is super flexible in getting some customized views built. Now the question is, OK, do we have enough operational capacity to scale? We see tremendous results. We want to scale the project. But do we have enough operational capacity to scale? So here, in this view, we are seeing the call answering capacities of individual reps. And in the line graph, you'll see when we introduce a new cohort to be routed, the reps are functioning at maximum capacity. The call volume is high. But due to their effectiveness, they're handling customers effectively, and they're resolving their problems faster. So due to their effectiveness, they're reducing the call volume. They're reducing the need for customers to call us multiple times. And so the call volume goes down, and there comes a point where the reps are underutilized. And it is at that point of time we want to introduce a new list. So you can see the cohort A is introduced, the call volume is high, it goes down due to the effective handling by the reps, then we introduce cohort B, then we introduce cohort C. And the capacity utilization that you see is shown in waffle charts. So it's a good use case for waffle charts, which is not used in business often. But something that is again interesting is those percentage numbers that you see on top of these waffle charts, those are actual sheets overlaid on top of other sheets. And that's only possible in Tableau 2018.3 with the functionality of making the background transparent. So I was waiting for this functionality for a long time, signed up for the beta program, and I'm glad it's out there now, and we're using it right away. So now, how do we decide which customers fall in this next list to be routed, right? It is through this optimized routing scaling tool. And different teams in call centers, different business transformation teams, and us in data science, we come together, and we sit together, and we can just plug in the customer behavioral attribute thresholds to whatever we want, and get the new list of customers to be routed. And so, in a sense, there are like less Excel sheets being floating around. There are less individual stakeholders crunching numbers on their own. But using this tool, we can come to a consensus fairly quickly and not lose momentum in the project. So we use this tool a lot to introduce new sets of customers in our optimized routing program. The results have been phenomenal. And Greg will talk about the impact.
Thank you, Sid. So yeah, I think that dashboard and the series of dashboards is amazing. One thing to think about that Sid was just touching upon is we had a bit of human interaction at first. But when you think about how we can use machine learning and AI here is you basically have that capacity tool tell you when to trigger your algorithm. When that capacity tool hits that threshold, now you can trigger the algorithm, it picks the filters for you based on the optimal cohorts, and then distributes that list automatically into the engine needed to rep those customers to the right reps. So it's really taking the human element out of it and making us just way more efficient. So to get to the results, as you can see, customers are calling 43% less in this segment, which is phenomenal. We have 62% less dispatches going out to these customers. To no surprise that we're treating these customers correctly, they're happier. We are seeing increased sentiment. And one of the things that's also important outside of improved results for the business is that this is a customer level dashboard. I have never seen anything like this. We have never used anything like this, but this is just one use case. Imagine having your entire customer base all down, and you can detect outliers in several different use cases, all in one place. So I'm super excited about how else we can use this dashboard technology.
Yep. In the next project, similar to the call centers, where we have certain customers calling us multiple times, in our dispatch space, we have certain households that require multiple dispatches to be sent for troubleshooting their issues. And so the objective here was to monitor a geographical impact of the field technician dispatch activity to improve customer satisfaction. And when I say geographical impact, it is not only at the state and zip code level, but at the individual household level. So we get to see the individual households that are generating multiple dispatches. So we start with measuring and monitoring certain key KPIs, high-level KPIs that give you a sense of your entire footprint for Fios dispatch. And then we segment these KPIs by the type of customer, by what's driving the dispatches, so the trouble types is what we call as the metric, and by several other wireline infrastructure attributes that are related to customers' households that generate multiple dispatches. And then we take all of this data and plot it on geospatial heat maps and satellite maps. We've used Mapbox satellite maps and integrated with Google Street View APIs. So to start with, we look at our customer base of 6.9 million. We look at the number of tickets they've generated. We look at the ticket rate. We look at the dispatches that have been initiated. We look at the dispatch rate. And then we look at the actual dollar cost impact coming in from whatever dates you've plugged in. So the dates are hyper flexible here. Now, one feedback that we got from top level executives is, okay, it's great to see these key KPIs for whatever dates we've plugged in, but we want to know how these KPIs have performed over time. We want to see a historical time trend of these key KPIs. And this is a great use case for whiz-in tooltips. So now we can hover over these boxes and line graphs pop up, showing you the historical time trend of how these key KPIs have performed over time. Below these KPI boxes, we see a distribution of ticket rates and dispatch rates by states in a heat map style view, where we can intuitively gauge which states are overperforming or underperforming with respect to ticket rates and dispatch rates. Below the heat map, you're seeing a horizontal bar graph of the different trouble types of what's generating these dispatches. So that's T1, T2, T3, T4. These are the different trouble types. Now, I talked about we want the business experts to slice and dice data themselves and extract actionable insights whenever they want. So let me give you an example how that is possible in this dashboard. Let's say we want to dive deep into a particular state. We can click on, let's say, Massachusetts. And now all of the rest of the views in the dashboard get filtered for Massachusetts only. So now we look at, OK, trouble type T1 has the highest ticket volume, but trouble type T2 is generating the highest dispatch volume. So let's click on T2. And on the geo heat map, now I can zoom in to find pockets of zip codes that have generated high dispatches for the trouble type T2 within the state of Massachusetts for the given dates that you've plugged in. Hovering over these zip codes will give you further information as to what is our customer population, what is the actual dollar cost impact coming out from this zip code for the dates that you've plugged in and for that particular trouble type. Also, I can go further and click on a particular zip code, and you'll see the infrastructure information at the bottom of the dashboard gets adjusted. So we get to see what is the distribution of our architecture and of the premises, et cetera, certain key infrastructure metrics that it gives us good context with respect to high dispatch areas. So this kind of slicing and dicing comes in really handy when you want to see which areas are affected for weather-related events like snowstorms or hurricanes, et cetera. In the next view, we start with a key question. Does anybody live in this house? No? All right, I'm good to show this then. OK. In the next view, we start with a correlation matrix of dispatch rates and ticket rates. And it's a scatter plot of 500,000 zip codes. And the zip codes that have a high dispatch rate is shown in our target quadrant, which is in orange. So all those plots have a high dispatch rate and a high ticket rate. And let's say we want to dive deep into a particular zip code. The size of the circle shows you the customer population. So let's pick a high dispatch rate zip code where we have a decent customer population. And so I'm going to hover over one of the zip codes. And so you see NJ Westfield 07090 has a high dispatch rate for the given dates that we've plugged in. We don't know what these dates are, right? And all right, let's click on NJ Westfield. And what you'll find is the satellite map at the right zooms in to show you the actual households that have generated these dispatches. Now, let's try to find, of these households, which are some of the households that have generated multiple dispatches. And we can do that by plugging in whatever threshold we want in the filter that's on the top right. So dispatches more than one, let's put in 3 and see what happens. And the heat map and the satellite map zooms in further to show you those households that have more than 3 dispatches. Let's do dispatches more than 5. And now we can see that there's one street on which we have like 2 households that have generated more than 5 dispatches in the given time period. So let's click on one of the households. And the trouble type tree map that you see gets filtered to show you what has generated these more than 5 dispatches. So the T2 is the highest dispatch driver here. At the bottom, you see certain contextual metrics. So we pull in the actual string fields of customer narrative and tech narrative and what router does the customer have and certain other wireline information. And many times it comes in really, really handy to see the actual infrastructure on the ground. So that is possible through the Google Street View API integration. And now we can see the actual street and the actual household, which has generated high dispatches. So sometimes in the customer narrative, we find that, OK, the wires are hanging too low, or a particular household has been affected by a weather-related event. So it's good to see what's there on the ground through the Google Street View API integration. This has helped us a lot in the analysis.
Yep, so this one's important not because of also the value it's going to deliver, but this is the type of dashboard where we get a lot of questions about these KPIs. So it's going to reduce analysis time by 50%. So if you get a bunch of questions in an analytics organization, you know how important it is to automate those insights and then let stakeholders slice and dice. So this is what this tool is able to do. It's also enabling that geospatial technology, so we can now see which zip codes have high dispatches, which zip codes have really any poor KPI that we need to measure. Stakeholders can also see where recurring dispatches are happening. And I love the tool that Sid showed that you can put in 1, 2, 3, 4, whatever you need to then find those households that are the outliers. And also just the geospatial technology in general. So this technology, like before, can be used in many different use cases. It's not just this one for dispatches, but like Sid pointed out, any weather-related event, anything you're trying to map for your organization, you can use this technology with the Google Maps API to make that happen.
Yep, now we get to the digital products. So Verizon has launched and keeps launching several digital products to engage with the customers more and more. So last year, we launched our Fios chatbot on the Facebook Messenger. And the objective here was to monitor the post-launch adoption, acquisition, and engagement on the bot. So we monitored certain key metrics to basically hack growth, if I can say that, with respect to how many unique users and sessions are being taking place on the bot, how many interactions, et cetera. Measure product usage. I talked about interactions. We measured that. We measured what kind of functionalities are being used in the chatbot. We wanted to know what the customers are chatting about. It's a great avenue for us to know what the customer wants, because 1 in 3 people in the US are on Facebook, and customers are chatting on the chatbot, which is on Facebook, just like how they're chatting with their friends. So in an intuitive and seamless way, we get to know what these customers want. And then we wanted to analyze the bot intelligence to get a sense of, is the bot, what is the capacity of the bot to cater to these questions that the customer is asking. So we started with designing KPIs and computations specific to the chatbot use case. And then we monitored time sensitivities of interactions and the functionalities that are being used and when are they used. We measured the cost and revenue impact from the different functionalities that are being used. And to extract meaning from customers' chat sessions, we've conducted text analytics using R and Tableau. So we look at some of the word clouds, and you'll get a sense of how we understand what the customer's chatting about in the bot. So in the first view, you'll see we start with key KPIs on the left. We are looking at total interactions, and then we break it down by agent interactions and bot interactions. We look at how many unique users are there on the bot. We look at how many customers have authenticated their accounts on the bot. And we look at the deep link click-throughs that are taking place for whatever start and end date you want to plug in. All these metrics are also seen in the time trends. So there are line graphs with mean lines that show you some statistical significance for these KPIs. And using parameters in Tableau, one interesting thing you can do to these time trends is you can toggle the granularity. So if you would want to look at a high-level normalized view of like where the trend is going, I can now go to the trend level filter and select a weekly, and the graphs normalize. And if I want to get further normalized, I can go monthly. But then if I want to get to the volatility of these metrics, I can go at the utmost granular level of getting to daily. So the way we do this is using parameters and custom dates in Tableau. One other thing that's cool in this dashboard is you can see a time-on-time comparison for each of these metrics. So we got feedback from our stakeholders saying that, hey, we want to see how these metrics have performed, day over day, week over week, month over month. What is the performance? And so, again, you can use date trunks and extract weeks from the dates. You can use date diffs to extract, 1 week less, 1 month less. And you can tie that to parameters to now see the comparison change from a day over day of this to the week over week for whatever dates you plug in. And the color coding shows you if it's gone up or down, basically. So that's something interesting, a good use case for parameters in Tableau. It really helps set the granularity of the views. We've looked at how many customers are there on the board and how many interactions are taking place. But in this next view, we are looking at when all this activity happens. And you're seeing day of week graphs and time of day graphs. So we're looking at hourly activity that's happening on this chatbot. And let me give you a use case of when this becomes particularly useful. So last year, there was a major sporting event, a boxing fight, a huge boxing fight. And one of the functionalities that we have on the chatbot is for customers to order pay-per-view and VOD titles. So when I plug in the dates for the week of the fight, okay, we can clearly see that Saturday has got the highest unique users and the highest interactions. But what is happening on the day of the fight, which is Saturday? I can now click on Saturday, and all the rest of the views in the dashboard will get filtered. So now I can see the hour of the fight, 2100 hours. The fight started at 9 p.m. So this is the hour of the fight. We have interactions and unique users at its peak. And so let's see what is happening in the bot during the fight, right? So I'm going to click on 9 p.m., 2100 hours, and now I can see how many unique users have referenced the title how many times. Further, I can see how many of those references converted to orders. And a cool thing that we see is majority of the interactions are being taking place through the bot. The agent interactions have gone down. So actual human interactions have gone down. And that leads to less cost for us and more revenue from the title orders that have been converted through the chats with the bot interactions. So that was a good hour for the chatbot. In our third view, we look at the different intents identified by the bot. And the tree map below shows you the bot responses to those identified intents. Again, the intra-visual filtering here works really well, where you can click on one of the intents, and all of the responses get filtered to show you, OK, these are the XYZ responses that the bot is able to give back for that particular intent. The text analytics that you see on the right is to extract meaning from what customers are chatting about. And I'll just take a minute to explain the approach that we're taking here. So the initial utterances that the customer is typing in the bot, that gets stored in string fields in our raw tables. All right? We query those string fields, and then we do certain text pre-processing, which is basically, one, removing the stop words, like hi, hello, he, she. Then we do some lexicon normalization, which is basically removing the suffixes, words ending with ly, ing. Then there's some name entity recognition applied to extract the names of actors, to extract the names of movies. And then we tag for parts of speech. And then once this pre-processing is done, then we extract 2 keywords, 3 keywords, basically bigrams, trigrams, n-grams, whatever we want. And then the data is aggregated to the frequency of the bigrams occurrence. So what you're seeing are the bigrams in the word clouds. These are the 2 keywords extracted from the initial utterances that the customers type in. And all of this is done in R by a data scientist in our team who's way more smarter than me, Supreet Nuna. And he aggregates all of this data based on the frequency of the occurrence of the words. And then I bring it in Tableau and visualize word clouds, allocating color and the size to the frequency of the occurrence of these bigrams. So all of this has helped the product, our chatbot, a lot.
Yep, so one of the key things that why this was successful is a lot of your companies will have different product launches, and one thing you definitely know is that executives want to see results day one. This was a very heavy lift to make this happen, but this dashboard was able to provide those results quickly so the business can make decisions. It also trained and assisted the intelligence of the bot. So if you manage a bot or your company has a bot, one of the things you know is you have this response that you don't want to see. It's basically the bot saying, it doesn't know what you're asking me. What we were able to see is for every single category that a customer would ask the bot, how large was that response? And we're able to measure how that went down over time by continuously targeting those intents and then having the teams program those in so the bot knew how to respond and take care of the customer. It also helped us with capacity. So those views that Sid showed you with time of the day and the day of the week and all those different things, that helps us plan. We need to know when we need to be staffed to help you on different events. So the key one was the fight. We needed to staff up. This helped us understand that activity and how many customers were engaging with us. And also, this is the first time we've integrated R with Tableau. So another really important point is continuously push your organization to innovate, to tie in different things with Tableau. The reason Tableau is so great is because it talks to all these different softwares. So for us, this was a big milestone of tying those two things together and getting text mining onto an actual dashboard.
Yep. So in our last case study, we'll talk about how we use data to enhance digital experiences. And the objective here is to improve the online renewal experience by analyzing different contract renewal campaigns. And with the goal that we want the customers to complete their renewals online on a self-serving basis. So for this, on the data prep side, there's something interesting. So all our online data is tagged via Site Catalyst and stored in Hadoop. But then all the call center data is stored in Teradata. So to tie in a customer's online behavior to their calling behavior, which is offline in the call centers, we first have to combine data from Teradata and Hadoop. And then once we have all done the ETL and got the tables ready, then we plug in to Tableau, create the extracts, and start building the views. And that's where we measure the success of the self-service by certain key KPIs. And we'll see what the KPIs are, and we look at it in a funnel type of a view. Then we monitor how these KPIs have performed over time. So basically, we monitor how the campaigns are performing over time. And then we compare each of these campaigns against each other to see which one is the most effective and what's working and what's not. So here we see this is our renewal flow. So for each campaign that's selected on the top filter, we see the number of visits, we see the number of visitors, the number of customers, the customers who called, how many calls they made, and the call-in rate. And you can see line graphs showing you how does that fluctuate over time. And something interesting that I want to talk about is we've integrated a cool feature, which is adding a dynamic text sticker to the bottom of the dashboard, which basically summarizes the entire information in the dashboard and gives you a brief of if the campaigns are doing good or bad, if the project is successful or not. And we've used JavaScript REST APIs and created the HTML marquee text stickers and hosted it on our internal servers, and then got that into Tableau dashboards through the URL embed functionalities. I mean, gotta love the URL embed functionalities. It just opens a whole new world of possibilities.
All right, thanks, Sid. So the funny story about that ticker is I was half joking when I asked Sid to incorporate that into the dashboard, and then came back 2 days later, and there was actually a moving ticker on the dashboard. So absolutely amazing, the fact that we were able to do that. So the key thing about this dashboard was what I mentioned before, which is more customers are digitally engaging now more than ever. This is why you need to put a heavy stress on digital analytics, making sure customers can self-serve. This is extremely important because this is our metric of success here. We pride ourselves on our cross-channel capabilities, taking customers who go digital and then have to call, and diving into that experience and figuring out why. This helped us identify those areas of opportunity. It helped us find which campaigns were working, which ones weren't, which ones confused customers, and just was very successful to keep optimize those things so more customers are able to close online. And just for the future use cases, this is another example that set the stage for how we would measure digital activity and the success of customers self-serving. This dashboard just provided us a stage to put many other dashboards on top of it and measure different pages. You probably have websites that have tons of different sections. They're all different in different ways. And you need to measure the success of those different flows and understand which ones need to be optimized.
Yep, now coming back to our session title, Advanced Visual Analytics at Scale, Empowering Actionable Insights at Verizon. So we looked at the 4 area-specific case studies, right? And we started with how we take big data at scale, how we ingest it, transform it, query it, analyze it, and then visualize it in the areas of call center operations and field dispatch operations, and how we use data to launch new digital products and improve the digital experiences, with the primary objective of democratizing data and empowering different stakeholders in the business, including operations managers, business transformation teams, product managers, marketing managers, software engineers, and our executives and the leadership team who set the direction of the business. But along the way, we've had challenges and learnings that we would want to share. And as a dashboard developer personally, myself, the first one really resonates, where know your audience. I mean, I can't stress enough. You'll save more time if you know who is going to use the dashboard and how. What type of functionalities are they going to use in the dashboard? What type of interactivities are they going to use in the dashboard? Based on that, you can create the appropriate views. So sometimes to answer just simple key questions, I used to over-engineer visualizations. But I've got that sense now of which is a good mix of a good view and the dashboard adding value through information. Like one thing is dashboards have to be information driven. However cool the view you built, if it's not giving the information that's going to impact the business, it's not that useful. I mean, people come to me and say, hey, can I take a screenshot and have this as my desktop background? I mean, I'm like, that's great. I'll take that as a compliment. But yeah, that's kind of insulting to me. Like, hey, why do you want to, it's cool that it looks good, but I want you to use it to impact the business. So know who's your audience. Minimize UI cognitive load. So we think about this a lot. And we use certain neuroaesthetic principles with respect to color palettes to make sure information is consumed easily and intuitively. And also, the information consumed retains for a long amount of time. And we do think about accessibility as well and use the appropriate color palettes in cases whenever it is necessary to accommodate everyone in the organization. The third one, anticipate the next 3 questions and proactively incorporate. Now, a good example that we saw was in the dispatch dashboards, the key KPIs that the executives saw. Like the next question that comes in the minds of top executives is, okay, what's the trend? How did these perform over time historically? So using real estate judiciously, we can incorporate the whiz-in tooltips. And so that's an example of anticipating a question in advance and proactively incorporating whiz-in tooltips to show you further information without disturbing the original view.
Yep, so to cover the last 3 challenges and learnings, we want to talk about the flow of information. Seen a lot of good sessions about this week. Make sure that your most relevant information is visible right at the top. You don't want people searching for that information that they need at the very core of what they're, on a daily basis they need to see. You also want to make sure if you're trying to tell a story with your dashboard, think about that story from your audience's perspective. Think about the flow of information. Make sure it makes sense to who's going to be viewing the dashboard. The second point is scalability. Get the data right the first time. Write the best query possible. Don't skip this step. Don't write the select star from where because it's easier. Write subqueries, write a very good query so your data loads as fast as possible. And if I had to leave you with one last point, in order for all of us to be successful and to push Tableau in our organizations, avoid slides and push dashboards. The next time you're in a meeting or you're preparing for a meeting and it's with one of your leaders and you know that you're supposed to make a slide deck, try a dashboard. Go into the meeting with a dashboard, put it on the screen, and just walk the person through it. We've done this with the president of our company, and it's been very successful. But you have to have them see the power of it. Let them interact with it, and you will be more successful. So with that, I just want to thank all of you for being here in the room, all of you that are tuning in live, our family and friends, and most importantly, the ACE organization and our Verizon friends who are watching back home. So thank you all very much.
Thank you so much. And one thing before we end, this picture is where we spend most of the time in the day. That's our ACE hub, that's our command center. And you can see the screens, and all of these dashboards are monitored, put up on the screen and monitored. And the last thing, please don't forget to review us in the Tableau app. If you like our session or if you have any other feedback, please do review in the Tableau app. That will help us improve. Here's our contact info. And if you want to find more about Verizon, these are the links you can visit. And thank you all for coming, and have a wonderful rest of the conference. Yeah.